Ninh. Anil, can you hear me? Anil? Mr. Anil? Majid, are you there?
Yes, sir.
So we'll start. I think last time we discussed about design and development. Am I right? It's a
Yes,
clause
sir.
3. Today we'll discuss. I mean, there are other 3 clause in clause 7. There are 3 subclause in clause 7. Okay. Uh, one important one is on the purchasing. Okay, which will cover. The later things are important, but we'll fast track. Can you see my screen?
Yes, sure.
Yeah, good. See, purchasing is one important thing which comes under clause 7 on the production and production control or controls on the production. And to me, I think when I was reading the MDSAP documents, okay, not ISO, uh, not ISO 13485, but MDSAP documents, I somewhere saw in the risk grading or grading of risk, also on the impact of the risk on the devices. Okay, this purchasing requirements were included in, okay, the one which have indirect impact. Okay, I mean, basically I don't agree with that. I mean, this purchasing requirements are purchasing material have a direct impact on the device or the product. But when I read the NC grading, as I told you some time before, okay, grading depends upon the, okay, direct or indirect impact of the clause or impact on the system, on the safety and performance of the device. Okay, like I do understand some of the clauses like 7.3 has a direct impact, management has a direct impact, documentation of course has, okay, clause 1, 2, 3 may not have so much impact. Okay, but some clause, I mean, very surprised to see, because I do understand that 7.3 has a very direct impact on the uh, product safety mainly, and also on the performance. Okay, do you agree with me on this? Do you agree with me that the material what we purchase or the services, the components we purchase will,
Yes,
yeah, will have a direct impact on the safety and performance of the device. So for me, this clause is very important. I mean, though it was mentioned in ISO 13485 that this clause is very important, but in the MDSAP documents, they have mentioned that this clause may not be, I mean, it has an indirect impact. So what we need to look into this clause is, this clause again is subdivided, or this subclause is again divided into, okay, 3 sections: 7.4.1, 7.4.2, 7.4.3, which are all related to purchasing requirements only. Okay. If we look into clause 7.4, okay, I said again it's subdivided into purchasing process, okay, purchasing information, verification of the product. These are 3 important, I mean, sections in subclause of 7.4. And these are very, very important. I know, like, there will be a lot of investigation, or auditors will go into these documents. Okay, purchasing actually this could be the first point of entry where they could enter into it. So if you look at the purchasing process, okay, you should not, I mean, this looks like a simple purchasing, like how you purchase in some shopping malls or like on Amazon. No, it's not that process. Though in Amazon you'll get customer ratings. Based on the customer ratings, also you can buy some of the, I mean, anything that you want on the Amazon, because they give customer ratings. Actually, most of the online apps give customer rating, but I'm not sure how true or how correct they are on the customer ratings. Okay, I also look into the customer ratings and select some of them. But here it is not similar to that. Why? Because we are here manufacturing medical devices. Okay, medical devices that is for the patient. It's not like we are purchasing some groceries or clothing or something for our fashion. Okay, we are purchasing material. It could be components or something like some services. We are hiring some services like that of calibration or sterilization, okay, or printing. Okay, as per a quality manual or quality management system, okay, and end of the day, it is going to reach the patient for a particular treatment and where safety and performance is guaranteed. Where you should, I mean, we look at the safety and performance, and indirectly it is linked to the purchase of the material. Okay, if your material is good of good quality, okay, most of the things will go right. Okay, if your process and other things are properly placed, a lot of things depend upon the material. So, to my common sense, material should have a direct impact on the safety and quality of product. Okay. The core concept in purchasing process is the organization must establish a robust process to control all purchased product. Okay. Ensuring suppliers are evaluated based on ability to meet requirements and the risk posed by the product or service. Okay, we are using two words. It could be a product, it could be a machinery, I mean, it could be a material, it could be machines, it could be any service. As I said, as I mentioned, like it could be here we mentioned components, materials, or services. So you need to be very careful about checking out with this, because this has very serious consequences. Okay. So what we need to do, get the right material or right device or right product or right component or right service. There is a protocol or procedure in the ISO 13485 which we need to adhere and we need to follow them. Without following these procedures and protocols, okay, one is, okay, you may be caught by the auditor, that's fine. If you get caught by the auditor, worst thing, he will give a major NC. Okay. But the worst, I mean, the unbearable thing that could happen is that if you are not following this process on purchasing requirements and other things, okay, you land up in getting, I mean, a non-compliance material, okay, not meeting your requirements, and this material when you have not verified it properly. I know, like many of us, okay, neglect to verify, just look at the document that comes from the supplier on the specification and look at our specifications and see whether they are matching. It happens many a times. Okay. Like there are, I mean, two things what happen is why to waste the material in testing them. Okay, already the raw material is coming from a non-customer. Why to test them and waste the material? Where that could be the some mentality of some of the management or even some QC guys. Okay, suppose I need to test 20 samples. Why to waste 20? It could be the components could be of high value. Okay. Some of the components basically in implants, implantable medical devices, or some it could be very costly. Why to test them and destroy them? You can just manage it based on the specification orders and all that stuff. But that is strictly, I mean, prohibited by the ISO 13485 clause 7.4. You need to test the materials. So, I mean, before going to verification of the material, and also ISO has provided some, I mean, like guidance how you should go with the suppliers or vendor. It's not like you directly jump into the supplier and say that, okay, this is my specification. Okay, we'll sign it. I need it for next 1 year. This is the amount, this is the quantity, we'll sign it. No, it has to be linked to the risk. The material has to be linked to the risk what the product will be carrying. Okay, there could be a lot of materials which you will be using in your production. A lot of materials that undergo process, lot of processes, but they could be some material which are very critical for the product, which dictate the safety and performance of the product. Okay, you can look into a lot of examples. Okay, for me, because I mean, I worked on class 3 medical devices mostly whole of my career. I worked on class 2B also. But if you look at class 3, suppose I have some implantable material that will be there in the body. Okay, a coronary stent or some heart valve. Okay, if I source the tube, okay, tube for cutting the laser cutting of the stent, and if I get the tube, okay, one is wrong dimensions, the other is the metal alloy is not as per the required standards specifications. Okay, this ultimately will lead to a lot of problems, including, I mean, there is a chance of death also. Okay, if the material composition is not same for the tube, or if the tube dimensions are different. See, in life-saving devices, you will have very narrow range or narrow standard deviations like 0.2 mm or 0.3 mm, unlike class 1 or class 2 devices. And you need to be very careful in the material selection and also verification. So these are high-risk material. So you need to grade your supplier based on the risk of the material which you are purchasing. Okay, suppose I am purchasing some plastics for the hub or something like a cotton or something, the needle tubes, something for welding process. Okay, that's fine. But when you're talking something, I mean, you should look into the product and see which components are very critical, okay, crucial for the performance of the product and also on the safety issues. So based on that, what we call it as supplier qualification matrix. Here you can see, okay, the auditable evidence is supplier qualification matrix. Of course, I'll share the SOP for this. A documented system classifying suppliers. Okay, example, he is a very critical supplier because the material what is supplying is very critical to my product, high risk material. Okay, major or minor. Something like you may outsource some services, like I know like they are important. All of them are important, but when you grade them, some of them will be more important than the other. Like suppose I get some packing material, cotton, may not have so much of direct impact. But I know tieback pouches or sterile barrier system has a direct impact on the sterility and bioburden. Or labeling, you can check the labeling, the mistakes in IFU. That's come as minor. It could come as major. There are few things which may come as minor. Mainly in the service sector that I'm talking. Okay, like sterilization becomes very major, or I should say it will be in the critical. Okay. calibration will be very critical. Okay, so I mean, what I'm trying to make you understand is like you should grade your suppliers. Okay, create a supplier matrix like, okay, this grade is critical. Because when you're grading the suppliers, I'll tell you later, your supplier audit, your supplier inspection, your verification of the supplier or verification of the material also should be in line with that. If I say this is a critical material and he is the critical supplier, I need to have a lot of control standards, supplier audits, okay, re-audits, verification of the supplier, verification of the material. Okay, if it is a minor one, just you can be okay. He may not have ISO 13485. If he has ISO 9001, still it's fine. But all critical suppliers should have ISO 13485 and should have proper documentation, QMS documentation. So, first is the control type and extent. The degree of control applied to supplier. See, this is what I am trying to make you understand. What is the degree of control applied to the supplier? How much degree of control you are having over the supplier? Okay. And its products must be proportionate to the risk associated with the purchased products, impact on device safety and performance, and compliance with regulatory requirements. See, this is talking exactly like what I told. How much control you have on the supplier? Okay, it should be proportionate to the risk, and the risk always directs towards safety and performance, and it also has to comply with the regulatory requirements of that particular country. Suppose if I go to US, US has a very stringent norms like, no, they say you need to squeeze the tolerances. You should not have so much of deviations or tolerance. You make them narrow. Okay. Uh, for suppose like there are some countries where still they accept some tolerances which are broad like in India. Okay, they give us some liberty to work on that. Okay, yeah, something like you see in, I mean, I'll quote an example, not in medical US, of course in medical US also. See, US FDA plants or 510(k) approved products have a very narrow tolerance, or they seems to work better in quality and performance. Okay, 510(k). I mean, if it is an FDA approved manufacturing unit or if FDA approved manufacturing facility, everything will be very tight. Okay, very systematic. Okay, even of late, even MDR, I mean, ENISO 13485 approved facilities are also now tightening it up. Okay, very stringently. Mainly, I'll tell you when I come to regulatory aspects on the PMS and other things. And I mean, I just want to quote like uh, in pharma, you can see like US FDA approved manufacturing facility in pharmaceuticals where they don't, I mean, they have almost like impurity levels of 0.0001 on any drugs or APIs. Okay, your material should be 99.999% pure. Suppose if you look at the CDSCO standard, they say if it is 99.8 or 99, it is fine. Okay, on the purity of the API on the drugs. That's why you find US FDA approved products to be very costly than that of the IMDR or CDSCO approved products because they have a very stringent tight control. So that I'm talking about the regulatory requirements depends upon, I mean, varies between the countries. This I told like you should have a matrix of critical, major, minor. Then based on that matrix only, you will be doing further activity on the auditors. How to deal with the auditors, verifications, audits, re-audits, verification of the material, all that will come. Okay, this is what I'm saying. Supplier evaluation and selection. Okay, supplier must be evaluated, selected, and periodically re-evaluated based on criteria established by the organization. Okay, what you will be evaluating? Their quality system maturity, audit results, okay, performance. What is their performance in the last 1 year? You can, okay, it's not that of late I know, like there is no monopoly. Like you need, there is only one supplier around the world, something like that. Okay, when I was there, when I was, I mean, 10 years back, when I was in R&D, there is absolute monopoly on some of the components. Okay, there is no second supplier. So it is inevitable that we need to buy that from that supplier. Okay, though the timelines were extended on delivery, or he may sometimes may not give us the time to do the audit, all that stuff. But I know pretty well of late, you don't have monopoly, you have multiple suppliers where you can select, or you can select all of them. Okay, you evaluate them. If suppose you have three, four suppliers, of course, you, I mean, on basis of your experience or going through some search engines or based on the other competitor experience, you will have some, okay, superficial idea on which company can supply best product, or which supplier can give us the best product. Based on that, you go for uh, supplier evaluation. Okay, for critical suppliers, it's better to have on-site audits, check their certifications, check their QMS. Like I say, I think I have not discussed about internal auditor training, but maybe once today we complete this, next two sessions we'll go for internal auditor training. Okay. Yeah. What I'm telling? Yeah, internal auditor training. Then I'll tell you how to do client audits also. Okay, client audit training also very important. And when maybe next after the next two sessions, I think you will be having an exam on ISO 13485 for giving you an internal audit certification. After I tell you, I mean, how the audit procedure, because you already learned 13485. And that's the reason I shared you a small 10-page, what we call a pocket book like, uh, class-wise what to remember. Okay, it's just every day morning you get for 5-10 minutes. In 10 days you remember everything. What are the clause, subclause, like Arulmati has a problem in remembering subclause. So you can look at the subclause and also give you some content and what are important points in that subclause or the clause. Okay, you just go through that just 5 minutes when you are, when you are alone or going to your company on your bus or while you're, walking or alone. Whenever you want, you can just have a look at just 5 minutes. It's very simple, very easy to understand. Okay, and very easy to connect. It's some 8 pages or 9 page. All clause I provided. Okay, and subclause I provided. And what is the important? Just I have provided 5 points for everything. Okay, 5 points which you need to remember for the clause and the subclause. Okay, I urge and I request you to go through that so that that will be imprinted in your brain. Okay, in your cerebrum, wherever it matters. And the second document I shared is that we'll discuss after we start the regulatory, this like regulatory sessions on IMDR, UMDR, 510K, and global regulatory standards. Okay, that is also something where I mentioned on 4-5 things, point wise, very precise, where you can remember. Okay, mainly on IMDR, UMDR, 510K, IMDR, sorry, I already told IMDR, risk management, and how they all these converge in regulatory compliance. Suppose I have 3-4 countries, I need to converge them in, okay, what is called as regulatory strategy, because I can't keep on preparing each and every section for all the countries. So I should have a strategy where, one, if I prepare a risk management document, it should cater to all the countries. So it should be whole and full, okay, catering to all the organizations. So that is the reason why I shared that document. Okay, the third or fourth one in that, how global regulatory convergence can happen. Okay, if you can prepare that, no, it looks great. Like you do it only once and you're catering to a lot of countries. Okay. Of course, on ISO, after internal audit training, I'll talk on MDSAP also, how to prepare MDSAP documents easily. Okay, the best way, I think, like if you have a good QA team, you can prepare MDSAP documents within 2-3 months and can have audit in 2 months. Maybe maximum of 5-6 months you can get MDSAP certification. Okay, I'll tell you how to do the gap analysis with ISO 13485 and make it very simple. Okay, getting MDSAP is not difficult, but the documentation is the most important thing. Okay, and the other document which I shared is on the capstone projects. I have designed 25 capstone projects. Couple of them are AI related, but that's what that's what will be the order of the day in next 2 years. Okay, my prediction never goes wrong. Next 2-3 years, you have to move into AML. At least if you start now, some of the projects, capstone projects on linked to AML, if you have gone through the 25 topics on capstone project, that also we'll discuss in detail. Like if you want to do project individually, you can do it, or 2-3 combined can do it. But end of the day, we need to publish it in a very good journal. Okay, for the topics, I also given an abstract. Also given a template like how you can write. I will be monitoring you from day one on what to do on that project. Okay, how we can bring some novelty in that publication. Okay, that will be great and interesting. Like, see, whatever I gave as capstone projects are people who are looking after 1-2 years. Okay, they are not, in that range of uh, current or concurrent range. So the MDSAP projects make you to understand, okay, what in next 2 years it is going to happen, and you will be well prepared, okay, ready for what's going to happen in next 1 year or 2 years, including everything. If I take, I already said to you, talked about you on integrating 1348 with AML, regulatory with AML, mainly the clinical part. Okay, the clinical is one of the important one which takes more time, but once you integrate that with AIML, okay, that also I'm going to tell you how you can integrate clinical, that's CER part, and integrate that with PMS, post-marketing surveillance. Of course, from the other side, other point, what enters in between them is the risk management. Okay, clinical, you have a PMS which is very, very mandatory as of now for EMDR, including IMDR. Okay. And then the risk. Okay. When these three converge, it will, you need to link them. I'll tell you how to link them and also link them with the GSPR or in your regulatory documentation. Of course, what we call clinical data management. Okay. I'll touch upon the CDM also. So these are few things which I have shared today. So first thing is go through the 13485, which is very concise. You remember the clause, subclause, and 5 top points which you need to remember in that. You will get the certification. CE certification if you can remember. Sorry, internal audit auditor certification if you can understand, remember the clause, and remember the top 5 points. Okay, I have not written it like a big publication generally which I do. And the second is on the regulatory compliances. I have given a short note also and few important points you need to remember, whether it's MDR or 510K or CDSCO IMDR, or on the risk management, or on the convergence of all this to make it as a global regulatory file. And the third thing is on the risk management. Okay. And the fourth is on the capstone project. So capstone project, we have some time, but it's good if you go through the what is the topic and what is the abstract I have given. You pick up one, okay, and keep doing some, groundwork on that. Start doing some spade work on that for a better understanding. Whenever you have some, if you want some literature, I will share. Okay, I want it to be published as a research article because all the topics which I gave are very new. Nobody has attempted in doing that. Okay, not as a review article where you combine some 20 or 30 already published article and make into one. No, you are creating some models or something different that than what is already happening or being done before. You are changing the rules of documentation in QMS and regulatory, which you will see that happening. You are, like you are in front trying to change, make these changes or change the rules. Okay, how fast you can do it and accuracy of doing that. Okay, I'll show you all the statistics on how accurate it will be. And it will, as I told now, it will bring down 50% of your time, whether it's clinical or risk. And the most thing is it will be there, ideally happening in a year or two. And of course, you will remember me throughout your life once you step into that arena of how, how fast the AI ML will integrate, mainly the AI will integrate, of course, some machine learning process. However, before the capstone project, I'll also teach something on AML, few important sessions, not the languages on Python or some other things. Few platforms which are readily available to use. Okay, there's no need that you have to be master in AI to do that task. Okay, it's just simply you need some data, some input data, and you have an AI linked process that I will tell you, then you'll get the output. So you need to be training the process till you get some accuracy around 99%, and there should be reproducibility. Okay, these are two important things which I will discuss. Of course, I have gone out of the context what I am talking, because this is the documents which I shared, and I know these are very, very important. Okay, moving further, if you want to learn, I'm already telling you what are the basics or what are the little bit advanced studies that are happening. See, I took like something 6 to 7 sessions to complete ISO 13485, understanding that this is the basic for both QA and RA. Okay, it's not only for quality guys to understand 13485. This I was telling repeatedly. ISO 13485 is mandatory for everybody in the organization. Okay, and that's why I took like almost 6 to 7 sessions. Okay, it's almost like 14 to 15 hours we have spent on this, and if you forget anyone or any clause, subclause, or some systems to implement on this, I think I'll be very unhappy on it. That's the reason I'll be training you on internal audit, how to do the internal audit, so that you can remember it much better when we enter into the practical approach of this. Okay. Yeah, we'll jump into this. So on supplier evaluation, so if you have something like, if it's not a monopoly, there are 2, 3 or 4 suppliers. Okay, if you love this make in India and buy in India, you can use, I mean, you can select Indian suppliers. But if you are more confident on quality of those suppliers abroad, still you can do your choice. Okay, but I suggest, like, based on the tariffs and all the stuff what we are having now on 50% tariffs, the import duty, I mean, and all these things, better make our system strong by buying. I mean, if it is not available, we can outsource. I mean, we need to buy from other countries. Of course, China is ready to give anything. Better to buy anything from India possibly. Okay. So, I mean, like, before you get into the conclusion of the material, you need to select them. Okay. Get samples from them. You know your specifications. Check their specifications, get samples from them, test them, I mean, also audit them, on-site audit, do a pakka QMS, like how you do for internal auditing. Okay, check everything from class 4 or from class 1 to class 8. Are they following the QMS? Okay. And then what you do end of the day is you prepare an approved supplier list. Okay, this is the auditable evidence. You will have a list of suppliers. Okay, these are upload suppliers. This list is upload. Okay, for critical items, I have this supplier, and standby or plan B, you can keep another supplier, because you don't know when that supplier will, I mean, the first supplier may not supply you on time, delay in deliveries. Okay, when your production is in full swing and the market is going so strong, okay, then it's obviously you should have plan B or second supplier whom you already evaluated and think that this guy is also good. Okay, this is very critical in supply chain management, that you should have an options. Okay, I mean, option B or a second option where you can buy the products. Okay, buy the materials from the suppliers. I mean, this is where we, India as a whole, went wrong in lot of other things, and now we are paying for it. Okay, of course, since last 1 month, Modi has diversified on the exports and imports. Okay, it's not just we depend on Russia or we depend on America for oil supplies, or we depend on China for our components or rare earths, all that. No, we should have our own, and India is perhaps, I mean, I don't know how much time it takes. We should be independent, self-independent in doing this, because we have, I mean, India itself has a lot of consumption. Okay, just we can live by our consumption of our own population, no necessity to even export. Okay, then you need to prepare approved supplier list. Okay, and I am telling you now, guys, this is the one they look at. What is approved, critical, major, minor? Then they will ask, the auditor will ask you a question like, how you approved it? Then you need to pick up all documents. Okay, he is 13485. I audited him. Okay, he has so many certification. I verified his, checked his product. Okay, I tested his product. His product is in within the, I mean, not within, I mean, like same as my required test, my requirements or my required test specifications. Okay, and we also have a supplier agreement that for so many years he is going to supply so that the supply chain won't break. It's not that he supplies for only one lot, two lots, or three lots for 3 months or 6 months. There should be a agreement that he is going to supply similar item, same item. Okay, and this is what I mean to say. Supplier control means in the agreement will write you are going to supply this product for us for next 3 years or 4 years, not product, I mean the raw material or any product or equipment. If you want to buy an equipment, you'll have an agreement that if there is something, if it is an equipment, it goes wrong. Okay, you are going to service it, you are going to bring the spare, there is a warranty for us. So all things you need to look in. It could be a component, it could be a raw material, it could be a service thing. Okay, you should be very careful because, as I said, first important thing is the manpower. Okay, we have seen that manpower is very, very important. The skills, experience, qualification of manpower. And second most important thing for any company is the infrastructure. And third most important thing is the machinery. Infrastructure includes the machinery and the raw material. You need to be very careful like what you are doing. So you should have the supplier evaluation records, whether you do on site or whether you do online also you can do audits. Okay. Something you have exports from Ukraine or some other places in West Asia where there is not possible to go on site and audit, or even Russia. There are a lot of places, a lot of wars are going on. So you can have an online audit, like you can ask them a lot of documentation, check them. Okay. Ask for a lot of reports basically. Okay. That is for supplier evaluation and selection. Then this is very, very crucial. I told you on day one. Suppose if you outsource any processes that comes in your scope, that comes in your QMS. Suppose I say I am outsourcing sterilization. Okay. And sterilization, I am supplying sterile products. I am supplying sterile products to the hospitals or the end user. But the point is, I'm doing sterilization or I'm outsourcing sterilization somewhere. Okay. Though you are outsourcing sterilization somewhere, that particular sterilization will become a part of your QMS and you need to have controls on what is happening to your sterilization. Don't leave it to the contractor or sterilization unit, which is performing the activity. So you should have full control whether this guy has done validations of the sterilization, whatever sterilization, gamma or ETO or autoclave, all this. Okay. He has done validation, whether he has that certification basically to do sterilization. Okay, what is the manpower, qualifications of the manpower to do the sterilization, and you should have a traceability of your products. Suppose you are sending 1,000 products for sterilization, and he has sterilized them. And what is the traceability you have that that 1,000 which you have given for sterilization are coming back? Or they mix with another product, because some of these organization sterilization unit, they mix up the batches with other companies products and do it. Okay, because sometimes if you give a small volume for sterilization, okay, they have sterilizer has a big capacity. So what they do is they mix up the products. They mix other company product with our product and they sterilize it. And there is a chance that their company product may come in our, and the end of the day, the traceability issues will come out there. So you need to be very careful while you are outsourcing these services. Basically, sterilization is one which has direct impact on the product. Okay, whether it's calibration, while you're working on people are, while you are sourcing calibration from outside, you need to see, okay, whether that is an approved organization to calibrate. Do they have the standards for calibrating? Are the persons who are doing the calibration have the qualification? Okay, there are a lot of things you need to dig in when you are outsourcing. Actually, you have to be very, very careful when you are outsourcing. Okay, then what you are doing internally. Because when you outsource it, most of the things won't be in your hand. Just you will be monitoring, doing a lot of documentation. But what's the real thing happening there? Okay, that has to come in the supplier agreement. Okay, any change that is happening in the sterilization unit or in the raw material supplier, complement supplier which you are outsourcing, he has to immediately inform to the manufacturer. If he changes the location of the sterilizer from one to the other room also, you need to inform. Okay, any change, little change in the process of manufacturing of sterilization, I mean, manufacturing from raw material, he need to inform. So for outsource process or what we call contractual documentation specifying their QMS compliance requirements, how they are having change controls, handling the non-conformities. So you need to look at the total QMS system, what they are having in outsource processes. Okay, do they have accreditations like the NABL? If you go for annual studies or bar competitor, do they have the certifications like CPCA, ALAC, or they are CIDISCO certified, what we call MDR certified? Okay, so you need to look and you need to have a plan. Okay, in the general requirement, that is what it says. Okay, established a robust process. What is a robust process? Means robust process means first planning how you are going to approach and what are the things which you are doing with the supplier. Okay, whether you are auditing or picking the samples or you will do the full audit or an online audit. Okay, and whatever the certification, make a list of things. You need to plan in a very robust way. Okay, are you verifying the product or going to talk to the top management, how you are going with the supplier agreement, what are the points you are including in the supplier agreement, because supplier agreements are done on bond papers which have, okay, which are to be legally binded because the top management signs on the supplier agreements. So if they do not comply with this supplier agreement form, if they have changed something and not informed to you, they are legally bound, I mean, bond for compensation, or they need to go to the court of law for settlements. Okay, these are three important things in purchasing process. Okay, purchasing information is very simple. Suppose if you give an order, first thing is, okay, you'll have the required information. Purchasing documents or purchase orders, contracts must clearly describe the product being ordered, including specific details. Suppose if you are ordering, giving a purchase order to some organization, it has to be in details with particular dates. What is the material you are ordering? What is the quantity you are ordering? Okay, perhaps the specification sheet of your requirements. Okay, of late, I mean, to my knowledge, I don't know what's happening today. To my knowledge, all critical suppliers names are decoded. Okay, are more classified. In the sense, a lot of people in the organization may not know where from this critical raw material is coming from. Okay, because if these things leak out, there will be a lot of other companies, I mean, which can copy or say, uh, do what you call Me Too products. I mean, some time back, earlier when I was in R&D, I mean, this is what we need to keep everything confidential. Mainly the purchase department used to decode them, not call by their manufacturer name. give them some numerical or alphanumericals, and we record so and so code, and what is the material supply. So some companies do that also. Okay. So you should be very particular about the purchase order. You need to verify twice or thrice whether everything is being ordered. So the auditable evidence is the purchase order. Okay, and all necessary information that is there. If there is something on material specs, you need to provide. Anything on the design and drawings, you need to provide. If you are say outsourcing the R&D or outsourcing the designs, this has to be pretty well documented. Okay, and again I'm repeating, the product specifications include what is the type and what is the class grade. We have different grades, classes for materials. Okay, like say analytical grade or HPLC grade, laboratory grade. Okay, class 1 or class 2 or medical grade, something like that. Mainly, medical devices company purchase medical grade. In that medical grade also there are different varieties. Okay, class 1, class 2, there are pharmacopoeial grades. Okay, and be very particular about the specifications, and not just specifications, and the tolerances of the specification. How much deviation you are given. Suppose your mean or average is 5. Okay, be very particular about its 5 plus or minus 0.5 or 0.2, or you can have a large leverage of giving 5 plus or minus 1. Then it becomes 6 to 7 or 5.4.82 if you give a small tolerance. I mean, this is very important when you give specifications. You have to be, okay, you will be very acquainted with the mean and average, that it should be 7 or 8 mm, 9 mm, or some weights. Okay, 8 grams or 8 milligrams, something like. But you need to be very careful with the standard deviations, drawings, process requirements, and part numbers. Part numbers is mainly for medical equipment. You need to be, because every part has a number. So when you combine every part, you should know which part number you are purchasing, because it has to be replaceable. No equipment will last lifelong. So the part numbers will be replaced. Okay, if there is a process requirement which you are, suppose there are components which are prepared. Okay, like IV sets or PM lines which you buy as accessories. Then you need to know about what is the material use and what is the process you are doing. Okay, that will be there, and it has to be mandatory provided by the supplier. Okay, and you also look at training and certification records. Supplier must provide evidence of required personal qualification of upon request. This is basically for the outsourced ones, like calibration or for biocompatibility or for sterilization. You should know they are trained or they are competent to do, or something like I have seen in some parts in Ahmedabad, not in every company. There will be they come as a daily wage laborers, not regular employees. They have daily wage. I was shocked, like every day new person is coming and he is doing sterilization. I was shocked, like whether you come daily. After that, I come when I don't have work. When I don't wait work other side, because this company pays very low for me. So you should have permanent employees who are trained. This is a critical service like sterilization or some other things, calibration. Okay. And also on the QMS requirements, total QMS, which you have studied as of now, we are in class 7. One class left is class 8, the interesting one. So you have to look from class 1 to class 8, whether they are documenting, recording. See, class 4 is all about documentation requirements. Class 5 management. Class 6 is on process controls. Okay. Sorry, class 6 on product. Sorry. process validation and process controls. Clause 7 is on product realization and provision controls. Okay. So you need to, once I train you on internal audit, you should be able to do even supplier audits. Suppose I tell you to do an audit of the supplier, what you will do first? Okay, first you need to have a planning. Okay, who are the suppliers of this product? Okay, my specification is this. Who can deliver faster? Who can provide me samples? When should I audit? Okay, because the certifications, what are the certifications available with them? Are they qualified? Are the certifications expired or still valid? A lot of the certifications I have seen with the biocompatibility testing laboratories, most of them will be expired. So you need to look at the validity of the certification. So you need to go in depth. Okay, and then comes the acceptance criteria. Okay, acceptance release methods of inspection must be communicated whether your incoming material. It's not that once you get the incoming material, you straight away give it to the production. Okay, once you get the incoming material, you have to keep it in quarantine. I think many of you know the meaning of quarantine. That's a buzzword during COVID. Okay. Quarantine, then you test the material. Of course, you will also look into a lot of records when the material was manufactured, what are the specification that comes from the supplier. Okay. And also you need to look, like suppose you are verifying. You also need to look at what are the procedures he is following to test or verify the product. Because the same methods you need to follow. Suppose you are following different modes or different procedures to test the product and he is doing some other, then there will be variation in your results and it may not comply. So you need to ask what are the methods you are following, what is the procedures you are following for testing the better, and same thing you need to do in your own lab once you get the raw material. Okay. So this is on incoming, if that passes. Okay, if your incoming material passes the test which you have performed in-house or in your organization, then only you will allow it to get into your stores. Otherwise, it will be in quarantine. If they are not meeting your specifications, you will return it back. Okay, citing so and so reasons, you can return it back. Okay, and the most important thing is like, as I said, you have a quarantine. Okay, suppose you get a non-conformity material not meeting your specification. You have to be careful that that material won't mix up with the other material. So it has to be totally segregated outside in the quarantine or segregated outside as a non-conformity product. Are you getting my point? So these are some of the auditable evidences like the supplier quality agreement. This is very important. Okay, incoming inspection procedure reference, you have a SOP, like suppose you get material, what are the things you need to look in? It's not that you directly take it and like how we do directly wear and check and it's returnable after 7 days or 10 days like Amazon. Okay, this is mostly on the verification of the product which I discussed. The organization must establish and implement the necessary. See, you keep hearing these words many a times in ISO. Okay, establish and implement. First is the document. Okay, establish, implement, monitoring. These are 4 words. Document, establish, implement, and monitor. Okay, some words are not given yet. Okay, establish and implement the necessary inspection or other activities to ensure that the purchased product meets the specified purchasing requirements before use. Before use, you need to cross-check, inspect all this just based on the document of from the supplier and your specification sheet, okay, don't approve the product. Suppose you have approved the product and it is a non-conformity product, okay, it enters into your production and you process the product, okay, by default you get some good conformity devices. End of the day, you'll have some devices which are meeting, which are in compliant with your technical specification, and these devices are in market. Okay, I'm telling you a practical situation. A non-conformity metal gets in, you have not tested it, but I said it's a non-conformity material. You have not tested, your purchase not tested, your QC not identified tested. But you give it to production. Production, as usual, goes with their process, and end of the day, you'll get some devices, okay, which are in compliance with your technical specification, and you'll send them to market. Then later you identify that this raw material, critical raw material, is not tested. Okay, what you'll do in that case? Your raw material is not tested,
Recall
but
that
processed. Good.
that would be very critical, sir. So risky. So we need to test that. If the material is not complying, a recall has to be initiated, I guess.
Yeah, I understood, but that device is already in the market. What you'll do? When people started, I mean, end users started using the product. But later, during your internal audits, you found that this material is not tested. Okay, it is not meeting your specification and it is a non-conformity raw material.
We
And
need to recall that.
yeah, the good answer is recall. But I mean, after 2-3 months, you have identified that it has been not tested. By the time 2-3 months, it would have been used, or there could be some complaints, or some issues would have happened. Yeah, I know that recall is the best option.
If it is used, then there is no any options. In many cases of this tent, there is a problem like this happen. We can't do anything.
No, if it is used and there is a complaint, will you link that complaint to the raw material?
Not at this stage, but after doing root cause analysis, we can find if it is in a raw material, then we can do these things.
Yeah. I'll tell you one, you said root cause analysis, no? I'll tell you one important thing. Of late, there is, I mean, as we move further, no, I told you it's more predictive analysis. Okay. Nobody is following the root cause analysis as of now. I'll talk on that later, but I mean, the best way is like you need to recall it, okay? And the second important thing is that you have to make your QMS mandatory, that every material that comes inside the organization has to be tested. See, that's why I'm telling you, if you don't follow some of the processes, no, I think these are all not so reasonable things. Okay, very old style. These are written after looking into a lot of angles, like what happens if you have not done these evaluations and other things. Okay, supplier verification, which we discussed, where the organization intend to perform verification of the supplier premises, the arrangements must be clearly documented in the purchasing information. You have a separate template for that. You need to fill what all they're doing. Actually, you need to look at the total QMS procedure from quality manual to SOPs to reports. Okay. Non-conforming product. If a product is identified as non-conforming during verification, it must be immediately identified, documented, controlled according to the non-conforming product. Okay, if you identify that it is a non-conforming product during your inspection, it is fine. Okay, it is fine and good. Like you have identified this is non-conforming. Suppose I'll tell you. I think I told to you also. So this comes as a non-conformity report. Then you need to send that non-conformity. This has to be discussed in length why you got non-conformity report. If you have not identified what it could have happened, you need to send back the samples and give a warning letter that this product has non-conformity report. It happens again. I think you have to mention that we look into other supplier or we need to close your file. Yeah, because that's a very serious thing, having non-compliance product or non-conformities which are outsourced. Yeah, like some sterilization thing. If you get some after sterilization, you get sterility reports as positive, what you will do? Okay, because sterility reports you get after 14 days. Okay, I'll talk on this subject later. Are people waiting for 14 days to get sterility reports and send their products? Or they are depending on the biological and chemical indicators to sell their products? I mean, to move their products in the market. Are companies waiting till 15 days to get sterility reports? The typical time to get the sterility reports is 14 days. I'm asking you, if it is a sterile product, are they waiting for 14 days to get the sterility reports? Are they sending it before sending the products into the market without sterility report? I mean, without getting the sterility report, based on biological indicators and chemical indicators that are used in sterilization.
Sir, they generally send that. They don't wait for the 14 days report.
If you find that they are not sterile, after you get sterility reports and you find that they are not sterile, okay, you get sterility reports after 14 days and you find them not sterile and you already have put them in the market.
Recall is the only option over here, sir. We cannot supply non-sterile products.
Yeah, I'll answer to that question when it comes. And the other thing most important, it's not there here. For the raw materials, how much sample size you have to take to test. Suppose you get 10 batches, 10 lots, something like that. You will test 10, all 10 lots, or you will pick, is there any specific sample size testing them? How many samples?
Yes, sir. There is a table in ISO. I am not able to recall the name of an ISO. So it has that if you have less than 100 batch size, so you need to take 2 or 4 sample, whichever is more, and more than 500, then you need to take 2 or 10 or 4 or 10% of the total batch size of the solution. Sorry, batch size, the lot size of that. So based on that, we can calculate.
Yeah, suppose if you test 4 or 5 samples, Okay. And you understand that out of 4 samples or 5 samples, 3 have failed or 3 are not within specification. What you will do?
I
We
guess
need to reject the batch.
batch release will not proceed. The batch has to be declared non-sterile.
No, will you go for retesting or you'll reject the batch?
I guess retesting.
You will retest or you will reject it.
We need to do retest, and if we find again uh, some sample like that means non-sterile, then we have to reject the batch.
No, it will be there in your SOP or it's your own understanding.
Sir, in pharmaceutical means in pharma industry, in pharmacopoeia, actually this practice has been mentioned for
Yeah.
pharmaceutical products only, but for medical device, I don't have any idea.
If it is sterility testing, suppose if you find the samples to be unsterile, uh, then you go for retesting or you re-sterilize the batch again. The problem is if you re-sterilize the product, conformity may go wrong. Or will you reject it? There will be 3, 4 options, like either you will test more samples, one, either you re-sterilize it, okay, two, or third is to reject. Which one you go if the sterility test samples show positive
Firstly,
results that there is a growth?
firstly, we have to select more samples and do the sterilization and find if it is sterile or not. If they get fail in sterilization, then we have to do the reject the batch.
Discuss on that.
Yes, sir.
This is on clause 7. I'll discuss, I mean, next we have that on sterilization and all. This is clause 7.4. That is clause 7.5. This is very big clause, like it has something like 7.5 has 5 or 6, but easy to understand. I mean, nothing critical to have. Some of the points I think I covered. Just give me 1 second. Yeah, today I went to Hyderabad, medical expo in Hyderabad. How many of you know there is expo in Hyderabad? Yeah. Okay. This is also part of clause 7. Clause 7 is on product realization and control of provision. Okay. So this is actually what exactly will be happening in any manufacturing organization. Okay. That's why it called most arguably the critical section of the standard, covering everything from manufacturing floor controls to validation of special process like sterilization. So what I meant to say is it controls everything. I mean, it talks about everything from, okay, everything from manufacturing till sterilization. How you need to monitor it, document it, or implement it, okay, record it, and of course to have sustainability of conformity products, how you need to maintain it. Okay. So 7.5 is production and service provision. This is very, very important. As I said, this is the actual thing where end of the day the company earns the money. How much production or what is the target, how you met the production, how many have you sold. So here you need to be very, very, very careful. And I think I told to you was somebody, because I of late have taken classes to lot. I mean, if before starting production, what is that you do? Okay. So the first thing is 7.5.1, how much control you have on your production and service provisions. Because this is a general requirement. But while you are planning, it's very common sense. Like when you are planning production, okay, it's not that one fine day morning you go and say, let's start production. Okay, things won't go like that. Because you need a proper production plan, okay, involving your quality people, QC people, okay, even some shop floor employees, equipment for calibration, okay, and also all process controls to check whether the machine is validated or not. So there will be any number of things that has to be ready, prepared, functional, okay, for you to start production. Of course, you need the material, raw material, you need the components all passed, verified, okay, and the competent manpower. And also in some situations, you need some skilled manpower to operate some of the machines. So, guys, what I want to make you very clear is if you are in production, okay, the important thing is like you need to have a proper production planning. Okay, how many I am going to manufacture? Okay, suppose I am going to manufacture 1,000 products, 1,000 devices. Okay, if I am going to manufacture 1,000 devices, suppose the rejection rate is 10%. Okay, think that the rejection rate is 10%. End of the day, okay, all components, online QC, in process QC, all that you end up with 10% rejection. Okay, and your rejection rate is 10% and you want to have manufacture 1,000 devices. If you want to manufacture 1,000 devices with 10% rejection rate, or overall how many you will manufacture? Did you get my point? 10% is your rejection rate and you want to manufacture 1,000 devices. Overall, how many you will manufacture to meet your target of 1,000 devices?
1,100.
Pardon?
1,100.
Yeah, absolutely right. You'll, because it's 10%, 10% of 1,000 is 100. So you will manufacture 100 devices more because you know the rejection, I mean, average rejection is something like 10%. So you'll manufacture 100 more. So if 10% goes to rejection also, still you will meet the target of your 1,000 devices that can be delivered to the market. Okay, I mean, this is what I am talking about production planning. How you will plan it. There are a lot of things which you need to do. Okay, statistically, there are some which you need to do based on your SOPs. Okay, there are some situations where you'll need the maintenance person to come in if something goes wrong. Okay, or there contingency plans for me to run production. Okay, because the marketing people will be crying you if you don't get the product, they say like when they have the product, they won't sell. When there are no devices, they keep on shouting that we have the market. I know typically how the marketing guys behave. I worked with them also. So you need a perfect Paka production planning to execute. And as I said, you need to have a standby systems in case something goes wrong, like your generator or your spare parts ready, your maintenance guys ready. Okay, if someone is absent that day, who is going to take the role in process QC or online or finished QC? Okay, how we are going to dispatch. So this all manpower, machinery, spares, maintenance, okay, backup, and total planning on material. These all things you need to prepare. Okay, cross check whether everything is available, inform them. This is what we are going for production, and next day you start your production. Okay, don't jump into production early morning. Once you come into the company, they say that today is Thursday or Friday, Saturday, very good day. In production, there is no good day, bad day. You need to plan your production. Okay, this is what control of provision and service control talks about. Intent is to ensure that all operational activities that affects product quality, including manufacturing, storage, installation, servicing, are planned, monitored, executed under strict control condition. Okay, including your storage. Once you get your no, you'll have 2-3 processes where sometimes some of the processes you need to have a storage of your components, or you need to do some assemblies. How you are going to store it? Okay, whether your device is properly installed, is it validated? Okay, or the servicing activities is there with the maintenance. All this has to be executed properly, planned, monitor, and executed, so that you'll get a good quality product with, acceptable rejections. Okay. Further, availability of information, the organization must ensure immediate availability of document resources, including the design master record. So you need to look at all the documentation that is required. You have the design master record, which gives the specifications, material specifications, okay, final device specifications, process parameters for multiple processes, multiple devices. Okay, what are the outputs, the drawings, SOPs, work instructions, and for QC people, what is the standard test procedures? All of them are available or not. Okay, that is what we call availability of information. Use of suitable equipment. The manufacturing, assembly, testing equipment must be suitable for the task and properly maintained. You need to cross check whether the available equipment, including your testing and monitor equipment, are available, are the functional, they validated, calibrated. Okay, the measuring equipment are calibrated and they give the right results. Okay, all this you need to cross check. Okay, basically it will be available at the machine itself. This is validated on so and so date. Next validation is this. So if it is within the validation time, you can go ahead. Okay, if the validation has expired, then you need to do another validation. Okay, even for the calibration also, with equipments, we have the calibration label, so and so date calibrated. So all this has to be maintained. Okay, first is the documentation, information, equipment, okay, and monitoring and measuring devices, all inspections, measuring and testing equipment. Okay, you'll be doing a lot of testing, QC tests, in process tests, online you will be doing, finished QC you will be doing, whether the equipment is there or there is lack of equipment, or the equipment is in what you call maintenance, okay, damaged, or is it calibrated or not. All these things you need to look at. Okay. Equipment and must be readily available and utilized to verify product acceptance criteria. Implementation of monitoring. Okay, defined critical parameters must be monitored and controlled throughout the process and records of them. For everything you need to maintain records. This is as clause 4.2.5. Okay, if any deviation is there, then you need to have a change control on the deviation. Okay. And criteria of workmanship, clear document criteria, visual standards, acceptance limits. So everything, most of the SOPs or specifications has to be ready with you. Don't think that I have it in my memory, I can just say it's accepted or rejected. Cross check with the documentation which you have, and only the maybe in next chapter we'll study on that. Whether rework is possible, can you do a rework, it is rejected, or can we repair them if it is a machinery, or can we accept under concession if there is non-conformity or rejected. Okay, prevention of contamination is very important. Resolution must be implemented to prevent mix-ups, cross-contamination, and environment degradation of the control. So this you clearly see, okay. Suppose a non-conformity and conformity product gets mixed up. Okay, there could be a mix-up of the material, a mix-up of, I mean, a rejected one and an accepted one, there is a mix-up. If you don't have proper traceability, or if your flow is not unidirectional, okay. So the best thing is whatever is a non-conformity, you need to segregate them with a pack and a label, red label on it that these are rejected. If there is a mix-up, there is every chance, and there is a chance that your rejected piece or non-conformity product, once it enters into the conformity product because of the mix-up, okay, the non-conformity product may enter into the market. Okay, there is total chaos there. You are not segregating what is right and what is wrong, what is rejected, what is acceptable. Okay, and this leads, there is a chance, many a time there is a chance this also leads to some of the complaints when you are non-conformity. So identification, what is the status, traceability of the product is very, very important. Okay, this contains batch manufacturing records, lot traveler, okay, process flow charts, work instructions, equipment maintenance logs, all this will be necessary for clause 7.5.1, which is very, very critical. Okay, you should have control on your production and service provision. The cleanliness of product and contamination control. This is mainly for the product which are non-sterile, and there could be some sterile methods where you do cleaning of the product, not the end stage sterilization, but you clean the product. Okay, and how you clean the product, how you make it, how you make them having less bioburden, less endotoxins, indirectly referring to less microorganisms. Okay, how you look at the cleanliness of the product and contamination control. To prevent and control contamination from foreign matter, residues, or bioburden. Okay, there could be contamination because of the foreign matter that comes out during production, or that can be with the machinery because of the lot of maintenance, oils, others we use, there could be contamination. And from manpower, human resources, there could be contamination with the foreign material. And if your manufacturing process is in clean rooms, okay, there could be contamination that could happen. Okay, I'm talking of the residues after production. There will be some material residues that may stick to your product. Residues like the oil and other engine related, machine related things that can stick to the product. And of course, bioburden, the microbial contamination that could adversely affect cleanliness, performance, and safety of the product. I'll tell you one important thing on this. Just remind me. Okay. If the product requires cleaning prior to sterilization or use, see, there will be some products you don't sterilize it, but you want to reduce the bioburden on the product. Okay, one is that before the use, you want to reduce the bioburden by cleaning the product. Second is you want to reduce the bioburden on the product. Okay, before the use, of course, you sterilize them at the end, but still you want to reduce the bioburden, so you clean it with ethanol or some antiseptic or some solvents. You can clean it. Okay, but the point is, while cleaning, you should not, you should also see that the product doesn't have any impact of your cleaning agents or cleaning solvents. Okay, sometimes alcohols or simple organic solvents will impact the product. Okay, when you started cleaning, that you have to rule it out. Okay. Yeah, everything has to be documented, validated. Validated means this is what I'm saying. The cleaning agent or any of the solvent what you are using should not have effect on the device and executed under control condition. Okay. This is prior to sterilization or use. Okay, some products I said just we clean it and use it without sterilization. Okay, like something like you have IV sets or PM lines, some cannulas. Basically, cannulas are sterilized, but those which are not in contact with body, which are very external, just we clean them. It's not mandatory that you need to sterilize them. Okay. Because they won't come in contact with the body. But if the inner lumen of the cannula is getting in contact with the body fluids, then you need to sterilize it. Okay, the inner lumen of these PM lines or the cannulas generally, they will be in contact with the human blood. Okay, and control of residues, what procedures must be in place to ensure residues from manufacturing lubricants, cleaning agents are below defined acceptable limits. Okay, this basically happens, I mean, practically I've seen when you have same product manufactured on the same machine. Okay, sorry, two different products manufactured on the same machine. Okay, you should have the first product residues will be there, which can have a carryover when you are manufacturing the second product. This is what we call as a carryover. You need to rule out that there is any carryover of the first material when you start production of the second material. Or else either you should have two machinery, okay, two machines, one for the one for one device, the second for other device. Okay, which will be bit costly to purchase the second or duplicate the second device. Okay, but most of the companies use the same machinery for most of the devices, but see that there is no carryover of the residues and it is properly cleaned. Like I said, manufacturing residues, lubricants, cleaning agents. Okay, control of contamination. First, devices supplied clean but not sterile. Are devices sensitive to environmental factors? These are basically the electronic components and implants which are very sensitive to electromagnetic components. Okay, you should not see that you are exposing them to a lot of electrical or magnetic environment or conditions, because when you expose them to electromagnetic conditions, there is a chance that okay, they may deform or they may not function well, because most of the electronic equipment and some of the implants which are metallic, which are alloys, okay, has a very important function related to their electromagnetic properties. Okay, mainly the heart valves, like, or some of the orthopedic implants or cardiac pacemakers, mainly the pacemakers, they have a lot of influence under electromagnetic conditions. So you need to see that you are not exposing, and you should have contamination control procedures, okay, in personal facility and material movement. Actually, the most important contamination happens by two ways. One is movement of man or movement of employees in and out of the clean rooms, because most of like humans shed a lot of debris that is there on their skin or on their scalp or on their hair, uh, I read somewhere that in a day we shed almost like 1500 microns of debris. Okay, every day. So that is very huge when you are entering into a clean room, which is classified as class 100 or class 1000, even class 10,000. Okay, you need to be careful. That's why we wear a lot of uh, clean room dresses or clean room caps and all that, so that there won't be any contamination. And the second thing is, second root of contamination is basically because of the material, movement of material. When you bring the raw material inside and you take out the material outside, the components, and there will be some chipping of the material that happens during the production. So cleaning becomes very important. Okay, if you are not cleaning properly, okay, what happens since it is a clean room? Okay, there is chance for the particulates matter to recirculate, though you have a very perfect HVAC system. Okay, air handling units, 7 cycles or 10 cycles per hour or per minute. The HVAC could be perfect. Okay, with all air filters and all that. But still, if these materials are within the clean room, okay, the debris or the chips that have come out of production, the waste material that has come out of production, or the material that has come out of the production because of the movement of the material in and outside of. What happens really, guys, is that they keep on recirculating, okay, circulating within. So you need to be very careful, okay, to clean it up every shift when you have done the production, okay, and check for any particulate matter. Not really validating the clean rooms, but check for any particulate matter. Okay, that is what I said. I said, no, I have the bad habit of telling everything before it comes. This is called clean room management. If production takes place in controlled environments like clean rooms, the facility must be monitored, classified, maintained according to international standard. What this is a standard for clean rooms. Okay. So it should be monitored, classified, classification of clean rooms, maintenance, there will be separate SOP. Okay, monitoring, there will be separate SOP, how you monitor, classify clean rooms. It has to be perfectly done. I know a lot of companies with clean rooms do this. Okay, evidence, key compliance, cleaning validation reports, environmental monitoring reports, particle count, microbial count, sampling, grounding procedure, clean room grounding procedures, material transfer protocols. Generally, you see material transfer doesn't happen through the doors. There will be some what you call exchange boxes. Okay. Uh, yeah, this will be meticulously done, but still there is a scope of contamination. I mean, it's better to reduce the particle size, reduce the bioburden as low as possible so that your sterilization will be effective. If your bioburden, I told you the other day, if your bioburden is more, what happens? If your bioburden is more during sterilization, of course you are doing an end-stage sterilization, but if your bioburden is more, what will happen?
Endotoxin limit.
What?
Endotoxin.
Yeah, endotoxin levels will increase. When endotoxins increase, your device will fail the endotoxin limit specifications. Okay, if you think that still it is fine, it's only endotoxin, but endotoxins are more dangerous than the microbes. Okay, because endotoxins will cause systemic infection. Systemic infections are that they infect your blood. Okay, total blood will be infected, and sometimes, okay, I mean, they cause very high fever, and typically, I mean, there are different ways how it causes fever. It has an effect on the hypothalamus in the brain. So there will be. So you need to be careful on bioburden. Better reduce the bioburden in all possible ways. Material movement or man movement or validation, cleaning of this. So whatever records they have mentioned. Okay, here. Cleaning validation, environmental monitoring record, particle counts, microbiological sampling. See, sampling, you need to check the bioburden weekly or based on your work activities that are happening in the clean rooms. Okay, whether you choose some, there are 2, 3 different ways, like air handling, you can do air handling equipment, where check the aerial bioburden. Okay, that is there in your clean rooms. And there is one called settle plate method, where they check the bioburden that is there in the flow. So when the air, I mean, when there is a bioburden in the air, it settles down in the petri plates. Okay, there are 2, 3 ways, and frequent fumigation of late you are getting aerosols. Okay, to fumigate. Earlier it used to be with the formaldehyde and magnesium sulfate something. Okay, I mean, this is the best way to reduce, and mainly for equipment or devices that you are manufacturing that enters into your blood circulation. Okay, device, a lot of devices that are in contact with your blood circulation, okay, or your cardiovascular system or your any device, you must see that you keep the, though there are limits, something like say 20 CFU for a device bioburden or 5 IU interrelational units for endotoxin. But forget about the limits and all that. Keep them as low as possible. Don't always try to look at. But inadvertently, though you work to your best, there will be a chance of some bioburden and contamination that we'll see. Okay, installation and servicing activities. Okay, to ensure that when the performance of the medical device depends on correct on-site installation, okay, the installation is carried out correctly, verified as functional before clinical use. So what we are talking here, it is the installation of the devices, okay, that you use. Okay, I mean devices that you are using for your manufacturing process. Okay, and sometimes the devices, installation of devices, okay, could be some of the devices where you see could be your own equipment which you are manufacturing. Okay, you need to understand it in 2 ways. One is the installation of device in your own organization for the manufacturing process, or installation of a device which you are manufacturing in other hospitals or other clinics, where here the medical equipment or SOMED will come in. So to ensure when the performance of the medical device depends on correct on-site installation, okay, the installation is carried out and verified as functional before clinical use. See, here it is talking clinical use of the device like the diagnostics which you need to install. Okay, installation procedure, verification and reports. If you look at the installation, a comprehensive validated procedure must be used, which specify the performance of this site and necessary tools, calibrations, personal qualification requirements. So the installation procedure, basically you will get it as a manual. Okay, it's not that you will get, maybe it could be some of the SOPs made into a manual, you will get as a installation manual for that particular machine. So based on the manual, you need to, okay, install that, validate the procedures, okay, and you need to check whether necessary tools are there for installation. So all these activities will be there written in the installation manual, but you need to record them. Okay, when he is installing, what are the spare parts he has done? What is the number of this part, spare part number? What is the validation he has performed? Okay. After, then comes the verification. After installation, the device performance must be verified against predefined functional specification and acceptance. So once you install the device, okay, the performance of the device must be verified. See, there are two things I think already discussed in design and development. One is verification, the other is validation. For those things which you can't, okay, verify, you need to validate. But here, if validation is possible, okay, validation is input versus output. Okay, so verification is input versus output. Validation is something for a particular intended use, or you meeting the requirements for the particular intended end use. It could be any validation, like we discussed some time back. It could be sterilization validation, packing validation, even clinical validation. Okay, that's a clinical validation is clinical trial that we discussed in design and development. Okay, and this all you need to be maintained in the records. Okay, this for any energy you see, Arulmati, one thing you need to remember. I think, I mean, for you, I have shared you one handbook, like to remember the clause, subclause, and the content in that, in the
Okay,
group.
sir.
Okay,
Okay,
you
sir.
go through that and read only 5-10 minutes every day for 2-3 days. You'll remember it. Even in
Okay,
your
sir.
sleep also, you will have them in your dreams. Okay, from class 1 to
Okay.
class 7. In your
Okay,
sleep
sir.
also, you will be murmuring that. Okay, for installation, actually I shared that for regulatory also, but we'll discuss on regulatory things later. First, we'll close on with ISO. Okay, servicing, I'm sorry. Key compliance evidence here is installation instructions, validate verification protocols, signed installation records. So both the parties has to sign it. Those who purchased and the supplier, or the guy who installed, both has to sign it. Okay, that records has to be maintained. Okay, there will be some more other records, like they will use some spares. Okay, they will also, I mean, it is based on your order. They will also give you some maintenance instructions. Okay, and also they will provide you some training. Okay, that all comes under records only. Just not only installation record, you need to work on that. Okay, I mean, sorry, document or record it. And servicing activities. See, this installation and servicing activities are not applicable to some of the companies where they don't manufacture medical equipment. So that's why I think I told you what is not applicable, what is exclusion in the scope. In clause 1 only, I said there is a difference between exclusion and not applicable. Okay. This is servicing activities, but servicing activities are very important because they'll talk about much on your servicing activities are like the PMS report. Okay, to ensure that necessary servicing, maintenance, repair is performed in a controlled manner. Okay, necessary servicing, maintenance. Okay, every company will have a maintenance department that looks after the devices. Okay, or repair of them. They will have, if they have spare parts, they can repair. And the problem here is like if the machine spares are not available, if you need to outsource them from other countries, it takes a lot of time. So it's always good as a preventive maintenance. There will be one called preventive maintenance. Okay, as a preventive maintenance, you should have all spares and a skilled person to repair it whenever there is a particular problem with the equipment. Okay. Okay, control of documentation, servicing must be performed using control current procedures, service manuals, and approved parts. But here I want to tell you one important thing. This servicing, everybody will do it, and there will be annual maintenance servicing. Okay, if the device doesn't have any problem, also they will do annual maintenance. Like for our house or some industries where they allocate some fund for annual maintenance. Simple, like say having waterproof painting or managing the clean rooms, environmental monitoring. That will be, I mean, every company maintains that annual maintenance program. For machinery also, you have an annual maintenance program. But what I'm talking here is a preventive maintenance. So preventive maintenance is which you don't know that it will happen. You can predict some of the things, say, after 10 or 12 runs or after some 20 manufacturing cycles, there will be some maintenance that has to be done. Preventive maintenance that happens suddenly without any, I mean, we can't predict what happens, and suddenly, I mean, it will be out of process parameters or you won't get a proper output. So for this, you should have preventive maintenance. And this preventive maintenance has to have skilled trained people. Okay. Missionary is very different from how the shop floor people work. Okay. This is what you should have approved spares, and this is very difficult. See, you cannot have one. Suppose you buy a machine from one vendor, you can't have a spare from other vendor and keep in this until exactly they match and somebody approves it. Okay, changing the spare parts from machine to machine will create a lot of problems. So better to have the spare parts of the same machine, because I mean I worked on the shop floor for a lot of critical equipments like laser cutting machines, stunt coating machines, like the express. Okay, multi-lumen extruders, like it extrudes 3-4 lumens at a time. Or a equivalent part specified in the procedure may be used for repair. Traceability of repair parts are replace spares. So you need to maintain the. Mainly, I don't think on the spare parts, but I've seen in many companies. See, every machine has some tools like molds or some artifacts like molds, okay, which are basically used for molds basically used for uh, printing or mainly used in plastics, okay, and some used for extrusion molds. So you need to have identification or traceability for that mold. Suppose instead of one mold, if you have used the other mold, it will lead to, I mean, a different component that can't be used. So it will be waste of time and waste of material. So traceability of the tools that you have built in-house is very important. Okay, I forgot, say something like in injection molding, you'll have different tools. For RF welding, you'll have different tools. There are a lot of welding processes and medical devices. Okay, radio frequency, I mean, RF welding is radio frequency welding. For extrusion, you'll have different tools. So that are the tools you have. You have the design drawings, you have the you have got it manufactured from outsource, but you need to be able to trace the tools. Okay, this is very, very important for production guys in tracing the tool. So service records has to be maintained. This is very important. Okay. How many times your equipment has gone into servicing? Is it happening daily, monthly, yearly once? So it speaks of the equipment health or efficiency of the equipment with the repeated servicing, repeated change of spare parts. Okay, those who are working in medical equipment, they are not there today. But I'm telling you, if there is, okay, there is change in the spare parts every day and out, and there is some problem in servicing with the machine day and day out, which means that the machine is not doing well, the health of the machine is, that you need to have it, okay, recorded, and you need to do the trend analysis and the cop-up for it, why it is happening. Okay, for medical equipment, it is like a PMS. Suppose I have a diagnostic equipment wherein I have installed, and there is a customer who is calling me day in, day out for servicing, which means the equipment which you have built, it could be diagnostic, X-ray, MRI, or some CT. Okay, there is always wearing of spare parts, and there is some issue with servicing every day, which means there is a serious problem with your equipment. It is almost like collecting your post-marketing surveillance data of the equipment. So servicing reports are very, very important. Okay, all service report and feedback must be systematically analyzed. This is what I am telling. All service reports and feedback must be systematically analyzed for trends, recurring issues, potential complaints, non-conformities. See, service reports for many medical equipment speak of the PMS only on how the device or the equipment is performed. So you need to have a record of this. Okay, the other 7.56 is particular requirements for sterile devices. The most important thing is the integrity of the sterile barrier system. So when you sterilize the devices, okay, before sterilizing, you pack them in, okay, sterile barrier systems. Basically, we call them as Tyvek or Tyvek pouches. We keep the devices in Tyvek pouches, which which acts as a barrier. Okay, it could be 0.2 micron. It looks like a porous paper like, okay, but resistant to heat and humidity. It has very less than 0.2 micron pore size. So it won't allow bacteria to enter into the device. So what we do is we pack the device with that pouch or Tyvek pouch and we sterilize it. But during sterilization, the gases or the gamma radiations or the humidity that can enter through the pores. So after sterilization, when you take them, there is no chance for outside bacteria to enter into the device. So we pack them in such a way, we call them a sterile barrier system or packing. And the control of bioburden are maintained before the sterilization process begins. Okay. Before you sterilize it, you need to pack them. Okay, then you sterilize them so that later after sterilization, there won't be any entry of bacteria through that Tyvek pouches. But for the Tyvek pouches, how you know that the Tyvek pouches are proper? How you check them that they are not allowing bacteria inside? Okay, have you verified them? Do you have any test to check this packaging material or this material that you use as sterile barrier system? Okay, so that they are not ingressing, okay, or entering into the device, okay, from outside environment, they are not going inside into the device after sterilization. So there will be some tests, what we call a sterile barrier test. There will be some bacterial ingress test. Okay, there will be 3-4 tests which you need to mandatorily do on the packing material to see that it is working efficiently. Okay. That is because sterile barrier system or control of bioburden. The organization document requires control measures for bioburden like the population, this we discussed. Either you can do settling plate method or air sampling method. Okay, input for the sterilization process. So what happens is, if you know what is the bioburden on in the clean room, and importantly, before you sterilize it, if you check what is the bioburden on the device, are you getting my point? You also need to check periodically what is the bioburden on the device before sterilization, and after sterilization, what is the bioburden? Similarly, the endotoxin. As I said repeatedly, if you reduce the bioburden as low as possible before sterilization, it is good. Okay, your devices will get sterilized, okay, at a Vmax dose, or I mean half of the Vmax, half dose of the maximum, what we call basically in gamma sterilization, and in half cycle, like within half cycle only they get sterilized, like in ETO sterilization. So the less the bioburden, the great it will be to sterilize your product, and the chances of failure of sterility will be very minimal. Okay, so I mean this is what the bioburden of the viable organisms serve as input to sterilization process. This includes control over the manufacturing environment, cleaning, and holding time. Okay, the key components is packing work instructions, how you are packing with the bioburden monitoring, pre-sterilization, environmental controlling records. And you also need to remember here, there will be some devices like that are used in biochemical process or biotechnology processes where they need zero endotoxin. It's not that they require zero bioburden, and those packages are those used in biochemical process I told you, like which are used in blood bags, storing blood or placental fluid or stem cells, like they basically require zero bioburden and zero endotoxin. So how you remove the endotoxin? There is a procedure or protocol even to remove the endotoxin. Okay, not on devices which which you have endotoxin limits, but mainly on the devices where there want endotoxins to be zero level, you have an SOP procedure how to clean them. Okay, this is on sterile medical devices. Okay, and in next 5 minutes I'll go this. These are special processes where the output cannot be fully verified for a subsequent inspection. We discussed that whenever verification is not possible, we have to do the validation. Okay, in design and development, I have clearly discussed. Okay, the best way to do, the best way is to do valid verification because it's the easiest. You have design inputs or inputs and outputs. You need to match whether they are in compliance with each other or there is any difference. If the difference is there, how much is the difference? 5%, 10%. It's the total outlier with 50% difference. So that is more a verification. You have inputs, you have outputs. But when this is not possible, when you don't have inputs and outputs like the process parameters, okay, you'll have only process parameters for manufacture of the device, but you don't have any inputs or outputs. Okay, then what we do is validation. Okay, validation is something like you need to meet the required, okay, intended use. Suppose I want to extrude, I am doing it on a machine, a validation. I want to extrude a 2 mm a tube or a tube, a plastic or a polymer tube with 0.2 mm or 0.1 mm internal diameter. Okay. What I'll do, I'll set some process parameters. Okay, I'll run it for 100 times. Okay, there will be a lot of what we call DOEs, design of experiment. There will be a lot of variables, heat, temperature, process run time, all this I'll adjust. Okay, I'll keep one as a variable and the other as a constant. Okay, then in the second experiment, I keep the other variable constant and the two will be changing. Okay, we keep experimenting with them till we get a consistent 0.2 mm inner diameter tubing. So we'll run for almost 100 or 200 samples. Again, it depends upon the sample size. So once you run and check them, okay, you're checking with your process parameters whether you're getting 0.2 mm ID. So once you finalize, okay, this process parameters are giving me 100 or 200 numbers, depends upon your sample size, with an ID of 0.2 mm cubing, then I will square onto the parameters, fix those parameters or zero onto the parameter, and then this parameter is final. Because I have excluded so many numbers, if you use the same machine, what validation means is if you use the same machine with the same process parameters, with the same material, okay, I can assure you statistically that 99% times, okay, if you get 95% times also, 95 with a probability of 95%, you will get and tube with ID of 0.2 mm. Okay, fight could go rejection. Your process is so capable. Okay, what we call CPK or PPK, that we can check by some equation, what we call process capability and process capacity. Okay, that there is a separate section for us to discuss process capability, statistical analysis, Six Sigma. How we'll do this? Because unless you talk on CPP, CPK, and Six Sigma, you are not really talking anything about your process. You are just a layman excluding something or manufacturing something. Okay, for you to be at a very different level as a senior person, okay, you need to talk on more technical terms on production, productivity. Okay, not just on, okay, accepted, rejected. Okay, if you are a QC person, you can do root cause analysis on the rejected samples. I'll tell you on that what we call trend analysis in clause 8. No, I thought I could complete clause 8 today, but I'm running slow or explaining too much. What do you say, Majid? Vaibhav? I'm explaining too much or running slow.
So
I
whatever
thought,
you're doing is good.
what?
Whatever you are doing is good and it's working actually.
I thought today I could complete class 8, but I'm running short of completing class 7 only. Okay, then the validation of sterilization, I told sterile barrier system process, this you need to validate. Whatever sterile barrier system you take, you need to test them. Okay, actually just wait. I switch from somewhere to other. Okay, special processes we talk, we need to do validation. Okay, we discuss validation is important when you don't have input and output, you have only process. The fix of process parameters, check how many, how much percent the probability that you are, suppose you have excluded 1,000 samples. In 1000, how many you are getting 0.2 mm ID? Okay, and go for the best process where you get 99% or 99% 9 times. Okay, you get 0.2 ID, but that's very difficult to have a probability of 99.99%. You are almost reaching 6 sigma. You know what is 6 sigma? If you manufacture 10 million, what is 10 million? 1 million means 10 lakhs. Okay, if you are manufacturing 10 million, it means 1 crore. You should have only 6 rejections, that is 6 sigma. Again, it depends upon a lot of variables. I'm looking at only one variable on ID, inner ID of the tube. Okay, 0.2 mm. But there will be a lot of other things like what is the roughness of the tube, what is the OD. You need to pick up 6, 7 things and see what are the rejections. So it's very difficult, I know, to achieve 6 sigma. I told you sometime. This is the one which is framed by Toyota Motors on 6 sigma. I mean, these guys do a lot of this, these Japan guys. They said like in 1 lakh, if you can get only 6 pieces rejected, then you are reaching 6 sigma. Okay, and that too depends on a lot of parameters which you are testing. It's not only your ID of the inner tube. Okay, I'll explain that later. Okay, then you need what is this special process? Whether you are doing welding, molding, this I have tell, RF welding or molds or bonding, heat treatment. Okay, you should have a validation protocol, personal qualification. For doing these validations and looking at the probability, you need to have some skilled persons, not just on that. They should have skill on the machinery. They should have skill on running the process parameters. How you prepare your design of experiment. Because just in one run you can't get it. You need to do 10, 15 runs. Okay, 10, 15 process parameters. Okay, then you'll select which one you are very close to. Okay, and they also should have some knowledge on statistics. Okay, root cause analysis. If it is not happening, whether the temperature is affecting, immediately they should try to adjust the temperature. It's not that you blindly run 100 experiments. If you run 100 experiments, it's not called validation, it's more a verification. Validation, we do it once or twice and get into the process parameters. Okay, nobody will do validation every day, but you can do verification every day. That's what your QC will do. What are my inputs? What are my outputs? Is verification. That is what QC persons will do. But validation of a process you can't do every day, because once you do validation, it will run whole day, and if you do whole day validation, when you will do the manufacturing. But you can do revalidation. Okay, that is what it's all. A documented schedule for periodic. Suppose if the devices what you have produced are coming out of specification, there are more rejections. You can do a root cause analysis because of material or manpower, or the manpower not trained, what is happening with process parameters. Then you look, there is something wrong with process parameter. Then you do a revalidation with the same process parameter. The same process parameter are not giving you 0.2 mm ID. Then change the process parameters, because I am telling, I think I told you, as you run the machine, there will be a lot of parts that are variable of the machine, including your molds. Okay, the molds where I have got it, that will also be a lot of varying, whether whatever material you use there. Okay, it could be stainless steel or some alloys, even titanium, like that will be variable. Okay, as will run it. And most importantly, you need to remember there will be 10% of machine depreciation. Okay, the performance of the machine will be depreciated 10% every year. Okay, this is, more an arbitrary statement. On an average, I'm telling, every year your performance of the machine will come down by 10%. Like how we have our four-wheelers or two-wheelers. After 10 years, it won't be the same. Okay, it will be like a Dakota, which you need to resell and buy a new one. So for machines also, see, every year 10% depreciation on the performance means after 10 years, though you do a lot of preventive maintenance, other maintenance, after 10 years, it performance will come down, it needs a lot of repairs. The problem is if I just laugh for a second, I'll get hiccups. Not no, from my birth, I used to get hiccups. Don't know why. Anyone has remedy, let me know on WhatsApp. So key performance, we are looking at revalidation. So you can revalidate based on, again, on the sensitivity of the machine and the parameters which you are monitoring and the tolerances. If you have broad tolerance, okay, it's fine. If you have very narrow tolerances, you need to revalidate every 2 months or 3 months. Okay, some machines we revalidate yearly. Okay, some like sterilization we need to do repeatedly because it carries a high risk. So high risk devices, equipment, machines, you need to revalidate quite often. Okay, sterile barrier system, I told you, we need to do sterility validation like this now I explained. Okay, check for ethylene oxide, how much ethylene oxide I have to give. What is the humidity temperature? These are already fixed. It's not that new thing, but based on your devices and the capacity of the machine, you need to readjust some of the things. Okay, even steam like autoclaving, radiation, gamma radiation, how much dose you need to give. Okay, we call it more mapping of the radiation or dose mapping we call. Okay, all this you need to validate. There are standards. Don't do as you like. You may be expert in validation, but I have a lot of respect for people who are good in validation. Okay, it's a very tough job. Like, first is tough job is on the design of experiment. Second is to be skilled on the machine. And the third is on selecting the sample size. Okay, the first difficult thing is on the variables which you are choosing on the. If you have 1, 2 process parameters, that's fine. Just temperature and humidity, okay. If you have 3, 4 process or 5 process parameters, okay, temperature, humidity, runtime, okay, and could be others like heating on the machine, the mold getting heated, then your DOIs keep on increasing. But there it comes your, logic or common sense. Once you do one DOE, you should be able to understand what are the parameters that are affecting. Maybe in second or third DOE, if you are smart enough, intelligent enough, logical enough, in 2, 3 DOEs, you should be able to square onto the process parameters for validation. Okay, even for sterilization. Okay, identification with these two I close. Identification is one, okay. For every device, you should have an identification mark, okay, a number, alphanumeric. Of late, some are printing directly on the device the identification number so that there won't be any mix-up within the company. Okay, non-conformity and conformity should be mixed up. Okay, the complaint samples which you get should not be mixed up. There will be a lot of mix-up happens in small companies. Okay, in small rooms where they do manufacture all of the activities in one room. Okay, sometimes this non-conformity may slip to the other. So the demarcation and identification, okay, is very much important by labeling them. Okay, what is non-conformity? And if it is a non-conformity, why it is a non-conformity? So to ensure that the product is uniquely identified throughout all stages of realization from raw material, okay, to the finished good, you need to be able to map the device. Okay, that is what we call identification, preventing mix-up, clearly indicating its status. So you should know what is the status. Is it at a semi-finished product stage? Semi-finished product stage means what is the size of it? If you have multiple sizes, what is the size of it? When it is manufactured, is it an accepted or rejected piece? Okay, all this data has to be there as a label on that pack. Okay, if you have some 10 pieces or 100 pieces, you can combine them. If you have only 1, 2 pieces, still you need to write, because identification is basically to avoid mix-ups and see that you are restricting the non-conformity product going out into the market. Okay. One is product identification. The product must be identifiable by size. This is what type of device. If you have 2, 3 models, okay, what is the size of it? What is the model? Okay, throughout all stages from raw material to finished goods. This is very important product identification. If you are failing to identify your product from raw materials to finished product, or finished product back, retrieving back to the raw material, either way, I think you will get a major non-conformity if you are not able to do that product identification. Status identification is whether it has been rejected or accepted, or you are going to rework on it, or you are going to repair it if it is a machinery. But that has to be separately segregated. Okay, what is the label? This is what I'm telling. You need to label it with tags. Labels or tags, batch number, lot number, status flag. Status is like whether they are rejected, reworked, under test or quarantine, accepted. See, you have so many things that are moving in your organization. How to identify them? You need to have this. Whether it's accepted, under test, quarantine, rejected, reworked. So you need to have these tags, labels or tags, batch number, lot number, status flags, okay, and control areas for segregation. Once you segregate all of them, which are under rework, accepted, rejected, it has to be separately segregated under different rooms. Okay, I know like few companies have this. If you don't have space, you can demarcate with a tape on the floor. Okay, red for all rejected, green for all accepted. Okay, some, I mean, lining, some tape for those are under rework, something like yellow under rework. I forgot the color, but basically red is for rejected, green is for accepted. If you have a small room, if you have separate rooms for this material, that is fine. Okay, traceable. We talked about identification. This is within the organization till you find out. Traceability is something which you need to have. Again, it is going beyond. Like from raw materials to finished products, you can identify, okay, through this. This is what we call identification. But traceability is something which you need to identify the device, or the hospitals need to identify the device. Once it goes out of your organization, out it steps from the gates of your organization into the market. Okay, the device need to be traceable. And of late there are lot of standards that have come in traceability. When I discuss about EU MDR, MDR, EMDR came with a very perfect traceability, what they call UDI, DI plus PI. IMDR, Indian MDR came out with neutral code traceability, but that is not perfect. Neutral code traceability is not perfect. In India, it is okay, but if you export outside, you need to get UDI, DI. I'll explain to this when I come to the traceability on that, because when you have this UDI, DI, okay, plus PI, you can identify your device anywhere in the globe, any hospital. If they give you that unique number, okay, UDI means unique device identifier plus device identifier plus PI. PI is product identifier. It will be a 22-digit number, 23, 24-digit number, which comes as alphanumeric with alphabets and numeric, 24 number, 24 characters, and it will be converted into a barcode. So once you scan the barcode, it will tell you from which country it came, which manufacturer, which organization company it came, which batch it came, which lot it came, on what date it is manufactured, and what date it is sterilized, and what date it is going to expire. Though 100% traceability will be there with the UDI DI system. For high-risk devices like implantables, okay, generally it won't end up to traceability till the implant. Okay, you implant a stent or a pacemaker or a heart valve or an orthopedic implant in the patient. The story won't end there. You need to, follow up the patient, okay, after implanting for next 2 or 3 years. As per MDR, it is up to 5 years. You need to follow the patient how he is doing, because for implants they are high risk, life saving. Okay, it is talking most of post marketing surveillance after the implant. What is happening to the patient, whether he is dying on the first day or he is alive on the 5th day. So for 5 years, earlier this is what US FDA used to do for 5 years. Earlier, before MDR came, Europe used to do only for 2 years. But after MDR, they extended that to 5 years like US FDA. Like they copied what US FDA is doing. So you need to have a follow. Okay. And periodically you need to call him to the hospital and do some tests like ECG or MRI, CT, like whether the implantable device is proper or there is some issue with it. Okay, of late we are getting a lot of implantables. So you need to look into all these things, and you need to maintain the records, documents, okay, on the PMS or the patient for implantables. Okay. So one is identification within the organization, traceability once it goes out of the organization into the global market. Third is the traceability that is linked to the patient till he dies. Not he dies, for a period of 3 years to 5 years. Okay, you need to monitor and you need to publish that, what happened to the patient. I think this is God, so many are there. It's okay. This is taking care of customer related property. Generally, we take some customers related property, mainly that includes some of the fixtures or some of the test specifications, some documents of another customer. This happens when you are doing a contract manufacturing, or rather than we are doing a OEM for another company or own brand labeling for other company. They give us lot of material, like their fixtures, their tools, their printing material, their labels, their specifications, their designs. Okay, when you are doing for the third party, that is customer related property. So that we need to keep it separately segregated. Suppose if you have one customer, it is fine. Suppose you are doing OEM, or OBL contract manufacturing for 10 customers. So there is a chance that it may mix up with other customer fixture, devices, labeling. And when you're labeling, that label of one customer will go to the other customer label. This creates a lot of problem. So you need to separately segregate your customer related property. One is separately segregating them in a demarcated place in a room. Okay. And in a particular storage area because temperature matters. Okay. Labeling, handling of those has to be properly done. Of course, you have an SOP on how to manage handle the customer related property. Okay, the first one is identification and verification. I said you need to identify with labels or tags that this is customer related and verify that this is the customer related. Okay, could be components, fixtures, servicing tools. It could be documents also. Okay, how we are safeguarding the property must store maintained under conditions, separate storage conditions, prevent damage or deterioration. So some of the sensitive equipment material like the polymers, okay, some of them get degraded if you don't properly preserve them at some temperature like 25 degrees at some humidity of 50%. Okay, and reporting. If any external property is lost, suppose if the customer property is damaged or lost or misplaced, you need to report to the customer. So the key compliance evidence is receiving inspection records. Once you get the customer property, you need to enter into the logbook. This is what I have received with the details. I have received 10 items. These are the fixtures, these are the molds, these are the labels, and how many they have given. All these details have to be there. Okay. Storage logs where you have stored, and if there is any non-conforming property, if there is some which labels are not good or if the fixtures are broken, you need to report them. Okay. The last one is preservation of the product. Once your product is, it could be, again, I'm saying it could be a semi-finished product, a component, it could be a final product. Okay. It could be anything like raw material. You'll have a lot of processes. In each process, you will get some component. Okay. And when you assemble them, you'll get a total product. So you need to know what is the how to preserve them so that they won't be mixed up to protect the product from damage. One is from damage so that humidity or temperature won't damage, including the raw material. I'm saying deterioration basically happens with the raw material during internal processing inside your manufacturing unit. How you are handling, or you're handling in craters or in just you're carrying with your hands or carrying in sterile boxes or sterile bags, how you are storing, how you are packing, how you are delivering. All this is important for everything. I'm telling raw materials, components, semi-finished components, finished goods, even rejected raw material. Okay, how you have stored it. And also the complaint samples, rework samples. All this has to be, I mean, this is something, one is how you should know how to preserve at what temperature, humidity conditions, all that. And for everything, you should have logbooks. You need to enter them in detail. Okay, during an audit, some people will come and show you where are your complaint samples. Okay, then you'll pick up one complaint sample and show to them. Then they'll ask you, where have you entered this as a complaint sample? Okay, you need to show the record. If you don't have the record, it will become an NC because documentation of any product you are reworking or it's a repair, non-conformity, it has to be entered, everything. Okay, this except for receipt of raw materials up to the point of use. Okay, handling, storage, packing, delivery. Okay, delivery means basically the transportation, because for every material there is one called transportation validation. Okay, I forgot the standard, but I'll tell you later. We need to, it's not that we'll keep it in a van or something with AC and move the van, okay, all over the city. It is a more simulated technique. Inside the lab only, we simulated the transportation, how much time we need to order the condition. Okay, like if there is a free fall, what will happen? If it is totally packed, crunchly packed, what will happen? Because I have seen a lot of material like when you go, when they are outside India or import items when they are coming outside, they have a lot of validation. Either they come through shipping or through air route. Okay, within India, a lot go by road route. Okay, so we need to work out on what are the transportation, whether there is any problem. Because I have seen lot of complaints where the packing is damaged, okay, while delivering it to the end user or the hospital. You see, he will return the product saying the package is damaged. And I have seen like 5 to 10% of the products where there will be a damaged packing of the product and he will return it back. So you need to be careful on preservation, basically on the handling of the device, how to handle it, what are the procedures for handling, mainly if they are, I said, implantable device with alloys, no electromagnetic forces should be there. Equipment, how you are handling, they should be packaged, cartons. See, equipment, we do them with wooden packing, okay, and the labeling, like how you do it, how you are storing it, packing, and how you are delivering it. That is through transportation. So key compliance is storage condition, monitoring, you need to have logbooks. I'm telling you guys one important thing before I close class, and just document everything. Okay, don't leave anything. If you are on leave, also document it. If you have headache, also document it. That I have headache today. Okay. Temperature, humidity, inventory control procedures. What is your inventory? Packing, what instructions? Shipping verification. If you are shipping it, you need to have verification with your order report. There will be a lot of documents where you need to cross it. There will be document like conformity assessment sheet document. There will be one called what is that? Technical specification sheet. Some call it as COA, or you call it any COC or conformity assessment. So there are a big bundle of documents before you ship it. Okay, all that has to be verified. Okay, I want to thank you sincerely, mainly Anjali. Sorry, I mean, I've taken a lot of time. Anjali would be sleeping. So these are some of the compliance checkpoints, okay, which is for you, not for me. Because I have faced a lot of audits, supplier audits, internal audits, external audits, and I have done a lot of audits. I'm the lead auditor, so these are the things which where you need to do the documents. Okay, guys, take care and thank you very much for your time. I my due apologies for taking extra time for almost, I think, 1 hour. It should end at 8:30. Now we are at 9:30. Okay,
No, an issue.
you can order your food. Okay, on my name, I'll pay it for you. If you are in if you are in hostel or somewhere in the room outside, you order food from anywhere on Zomato or Swiggy, or you want to go outside, I'll pay for your dinner for today. Okay, take care and see you tomorrow, because tomorrow I'll be discussing on class 8, which I thought I will discuss today. I don't know. I think I'm underestimating the time or explaining too much, or I'm going very slow. Let me rethink. Let me see a recording of 1 2 sessions. I never look at the recordings, but let me check the recordings. Like I'm explaining too much, or I'm going slow, fast. Anyway, tomorrow we'll touch on clause 8. It is easy to understand and very interesting, and few clause, like up to 3 or 4 clause, we can complete it. I'm pretty sure in 2 hours we can complete. Okay?
Okay, sir. Take care. Good
Yeah,
night.
Good night, sir.
Good night, sir. Thank you, sir.
Take care. Yeah. Anjali could be sleeping, I think.